failover clustering, so it looks just like an extension of failover clustering. And all the control and management of your mirror can be done through failover clustering through our integration process. So the next point down would be enable the multi-site cluster. So up to this point, I've been talking about a product called SteelEye DataKeeper, which is our replication engine that can be used standalone without any cluster integration. If you simply need to replicate data from point A to point B, we have a lower cost, entry-level solution that can do that. The same solution with just a different license key to enable the cluster integration will now registers a special cluster resource called the DataKeeper volume and integrates with failover clustering. So you get the same great replication engine, but now all the command and control is done through failover clustering. And our solutions are certified for Windows Server 2008, 2008 R2, and Hyper-V. And we've recently, in December, won the Community Choice Gold Award for Best Disaster Recovery Solution and the Editor's Best Silver Award. So this solution is really been very well accepted, and the community loves it, and we're here with Microsoft today because we have a very good value proposition to add and extend to the Hyper-V clustering. So with that, let's move on to our first demo. We're going to start, I put this slide together, and I see start at the bottom of the levels of availability. I call it the availability ladder. So the very bottom level, all virtualization platforms promise easier disaster recovery, better availability. It doesn't matter what virtualization platform you're talking about, that's a basic promise. So they do that by encapsulating servers into a group of files. In the Hyper-V world, it's a VHD file and your configuration file. And then you can do easy hardware upgrades and easier disaster recovery, and all that's great. You know, with Microsoft at this level, we just heard a great presentation. They talk about data protection managers, so taking snapshots of that server, or any way you can get a copy of that VHD file, you can move it around and you can restore it. But it does no automatic monitoring or failover or anything like that. At this level, what SteelEye offers with our entry-level solution, just called SteelEye DataKeeper, is we can keep a real-time copy of a running VHD, a running VM from one disk to another, either from one server to another server, or even within the same server, as you'll see this slide illustrates. And this is a very simple way to ensure data protection with a simple one license of DataKeeper. You might have all your virtual machines running on the E volume that's sitting on your SAN. That's a very high-speed SAN, costs you a lot of money, but you want to ensure that if that SAN fails or you need to do maintenance on that SAN and you still need availability, we can at the same time replicate from E to F, and the F drive might be attached to an iSCSI array, or it might even just be a local disk. And so if you do have an unexpected failure, you can simply just rename F to E and start your virtual machines until you fix your server. So I'm going to show you how to enable that solution. I'll switch over here to the demo. Okay, so we'll start here with, I mentioned that we are a MMC snap-in, so I've built a console and I've added SteelEye DataKeeper along with Failover Clustering Manager into this console. And what I'm going to do is just show you how to create a mirror. So in SteelEye DataKeeper, we create a job and give it a name, which is called local replication, and a description. And we're going to replicate the X drive to the Y drive. And we'll create the job. So the first thing we want to do is choose the source. We choose the source system, VMC1, that's the server. Choose the network we want to use. I'll leave the default, but you choose basically the endpoints of the mirror. This is the network we're going to replicate across. And then we'll choose the target system, Again, it's going to be the same server. We'll leave it at BMC1, but now we'll choose the Y drive as the target. The third and final screen allows you to make some adjustments to the options. We have, as I mentioned, compression. So if you wanted to enable compression, you would do that here. There's 9 levels of compression. This is where you choose whether you want asynchronous or synchronous mirroring. And if you wanted to put a cap, a throttle on the amount of bandwidth we can use, you would set that here. But we'll just leave the defaults, and now we're creating a mirror from the X drive to the Y drive. So when that creates, we'll open up the drives here, and we'll see the Y drive is currently locked. So when we're actively mirroring, the target system drive is locked. We don't want you making changes on the target. You always make changes on the source. They're replicated to the target. So we're controlling that locking of the Y drive. So if I go to the X drive and I have some information here, and maybe I add a new text document, and it's VHD1. And this is just for demonstration purposes. This is just a text file, but the same process would work with your virtual machines as well in real time. So just save that. And then what I'll do is I'll go back here, and I can do a few things with this mirror. I can pause and unlock all the mirrors. I can break all the mirrors. I can simply delete the mirrors. So you have a few options. For us, maybe we'll just go ahead and delete the job and see what's sitting on the Y drive. So this is the X drive. We were replicating to the Y drive, and here's that file that we wrote on the X drive. Same concept for your VHD file. So that's very simple. It's almost like RAID 1, but across your network, and so it gives you a real-time copy of all of your data. So switch back to the next level up.